Hey everyone, thanks for joining our Keeper Secrets Manager today. Before we get started, just a few housekeeping items. This webinar will be recorded and shared with you afterwards. You can chat amongst each other on the chat on the right side, and then we will be having questions answered throughout the presentation. So there is a questions tab on the right. If you wouldn't mind, please just putting your questions in there so that we can prioritize them, and you can also vote on them amongst each other. So we will answer it throughout the webinar, as well as at the end, we'll have a few minutes left for any additional questions you have. So with that being said, let me introduce Craig Lurey, our CTO and Co-Founder, and he can take it away.
Thanks, Max. Hi, everybody. I'm Craig Lurey. I'm the CTO and Co-Founder of Keeper. Nice to see everybody. As I go through this, please feel free to just jump in with questions, and we can make this interactive. And that would be awesome. I'll go through just a quick deck, just what is Keeper Secrets Manager, and then I'll show a product demo and go through some use cases. And if anybody has any specific use cases that you'd like to see, I'd be happy to do my best to show them as well. So let's get started. So in this overview, this deck that I'll go through, I'll just talk about what is secrets, why are they important, and some of the use cases. Also, of course, pricing and how this is deployed to users. So secrets management, what is it? You all are familiar with the Keeper Vault. Our vault is used for storing and protecting any information in an encrypted vault on all your devices. And so the vault was designed to be used by humans, of course, and authenticated by users. And the methods of authentication of our vault are really meant to protect and to serve users on their devices. When it comes to secrets and infrastructure, we needed to create a whole new set of backend APIs and also machine-to-machine capabilities that allow you to work with infrastructure. So secrets that you can store in the vault are things, of course, like passwords, API keys, things like, let's say, S3 keys from Amazon or Twilio API keys, or a really common use case for a secret in our environment would be like an SSH key. So you can use the vault to store SSH, any type of private keys, machine authentication credentials, digital certificates. So things like SSL certificates are pretty common. And I'll show how to use SSL certificates in the Secrets Manager. And also, of course, things like one-time passwords, which is a custom field and available for users in the vault. So, of course, these things you can store in the vault today. They just show up as record types. But, how do you interact with those with third-party systems, and how do you use those for different types of use cases is what we'll cover in Secrets Manager. So, as you know, secrets are really the most desirable targets, and so the potential for breach is really large, especially when going to multi-cloud environments. So people are moving to the cloud, people have multi-cloud, you have your Azure, AWS, you have all your cloud services, and it's easy to basically forget where things are stored and where your configurations and your secrets are stored. So you've got things kind of spread and sprawled all over the place. So attackers are going after these privileged accounts because of course, they provide the most level of access into the organization. So Secrets Manager is a few different components, and we'll cover it in the demo, but basically there's SDKs in every language. There are integrations into common CI/CD pipelines and products like GitHub Actions and Jenkins and Terraform, things like that. And then there's some really cool command line interfaces, and that command line interface we call the Secrets Manager CLI, KSM CLI. It has a lot of special capabilities. So of course you can use it just like a CLI, but it can also integrate, and it can also be used with other types of programming languages. So we'll review that in this demo. The core target audience of Secrets Manager is really these three. And so there's different use cases for the different types of user. Of course, for DevOps teams, it's really about accessing infrastructure and to deploy software, to deploy code, or push through CI/CD pipelines. For IT admins, it's being able to access privileged accounts and being able to also utilize privileged accounts for establishing sessions and other types of use cases. And then for the software engineering use case, it's, the core use case there is really eliminating hard-coded credentials from software, from configurations, from flat files, and from especially from source code repositories, which is something that the product allows you to do. Will it work if the network connection is unavailable? Yeah, so we'll cover this for the that use case. So the Secrets Manager is a cloud-based product, and I'll kind of go over the core capabilities. I'm going to skip over these screenshots because I'm going to show that's not me doing that. I don't know what that is. Okay, I'm going to get out of this thing. Okay, I'm going to switch over to my computer. It was just jumping around screens for some reason. Okay, so these are the core use cases I'll cover. So retrieving credentials from the vault, updating. So it's kind of the CRUD operations, being able to receive information, download it, decrypt it, being able to update information, be able to generate new secrets or rotate passwords, that sort of a thing. And I'll show how to monitor usage, revoke access, and many different use cases here of the product. And we'll get through as many as we can. So we'll cover the deployment methods, but there's a set of core SDKs in every language, and then there's a CLI, which is really the used for several use cases. Now, to answer the question that was just asked, so the Secrets Manager SDK and the Secrets Manager tools, they all communicate directly to the Keeper Security Cloud, but there's also a local encrypted cache. So for Mark, who asked that question, you will be able to utilize our cache feature, which is always available for all devices, and there's an offline mode for our vault as well. So I'll switch over to the to my screen. Okay, so just as a background, and by the way, if there's any questions, I'll pop over to that tab and try to jump into those. So just as I always do with all of my demos and going through different new products, I always touch a bit on our encryption model. It's important just to get some quick background here. So this is also documented. So we've got our public encryption model disclosure document, and there's a section here called Secrets Manager Encryption Model. So it talks a little bit about that. So the way that Secrets Manager works is it's zero knowledge. We do not have the ability to decrypt our customers' data in the vault. And likewise with Secrets Manager, we do not have the ability to decrypt secrets. And that's a really big differentiator between us and other products that on the market. And in this model, the secrets are always encrypted and decrypted locally on the device. And then it uses 256-bit AES to protect and encrypt every secret in the vault. And then those secrets are wrapped by an additional key. We call it the shared folder key if it's contained within a shared folder. And then we also have an encrypted payload. So when you communicate between Secrets Manager and the system, we actually, yes, we encrypt every single secret. Those are also wrapped by another encryption key. And then at the TLS level, when you're actually communicating to our system, we actually have another payload. We call it the transmission key, which encrypts the traffic again with 256-bit AES, and that protects against man-in-the-middle attacks. So you can't man-in-the-middle our system if you try to use it over like an SSL inspecting proxy or something like that. It just breaks down. It won't work. That's it's got a lot of protection against that. So it's protection against man-in-the-middle attacks. It's got protection against brute force attack, and also it uses signing for every request. It's signed and then the signature is verified on our system for authentication. We also, in addition to that, use IP allow lists, so you can assign a specific IP that must be used by that device in order to communicate. So there's a lot of protection there in terms of how data is protected in the vault. So the different endpoints, I'll just kind of go into the product and show how this works. So I'll bounce actually between the console and the vault. So in the console, to activate this capability, first of all, how do you turn it on for users? So this is my admin console in demo environment. And so Secrets Manager is activated. If you go over to the subscriptions section here, you can turn it on. I, of course, have everything turned on, but you'll be able to activate that as a trial in your subscriptions tab of the admin console. And then you're going to need to turn it on. So this is turned on at the role level. So if you, for example, I have a node, I'll have a node called DevOps, and within this DevOps node, I've got some roles. There's a DevOps default role that I've assigned to anybody in this node. And under enforcement policies, you'll see there's a new enforcement policy down here on the left called Secrets Manager. So I have this turned on. So you can just turn this on. And so when this is enabled for a particular role, all of those users within that role get the Secrets Manager application activated, or Secrets Manager feature activated. So there's a question.
Yeah, I can read it off for you.
Sure.
So do you have documentation on best practices when it comes to the relationship between shared folder and keeper and different environments such as DevUS or DevEU? So should we create different shared folders for each environment?
Yes, great. So I'll show that next. So once you've activated the Secrets Manager, so now on the Vault side of things, you go ahead and log in. And in my case, I'm logging in with my demo user account, which uses Azure as the identity provider. And I'm using a hardware-based YubiKey device authentication. So I get the signed SAML back from Azure, and then it decrypts my vault locally. So this is just normal usage of our product. This is the user side of things. So the important thing is that, as a user, especially in DevOps or engineering, I can now authenticate into my vault, of course, on the human side of things using my identity provider, or I can use a master password, but most of our enterprise customers roll out with some sort of identity provider. So to that question, you've got information in your vault broken down typically by folders. And in this case, we'll talk about shared folders. So here I have one called Connection Manager Secrets. Here's one called Development Secrets. And to the question that was just asked, yes. So what you would do typically is that you would set up different folders for different environments. So I can just go in my vault and I can create a new shared folder called, let's say, QA environment. And then in this shared folder, I can assign the users, and the users, let's say I want to have the developers, and I'd give them the ability to manage users and records, let's say. And then under applications, this is the third tab that appears for Secrets Manager. Now I can assign applications to this folder. So this is really how you would do it. This is how you would separate the different environments. And so here's an example. So I have one for Terraform QA. So let's say I have a Terraform application in the QA environment, and I want to provide it access to the QA environment passwords, or secrets. So I can just go ahead and do that, create that folder. So that's how you would separate the different environments. So take a step back. Just inside of the vault, you've got the ability to create different types of records. Now, we do recommend for best practices to separate environments using shared folders, but you actually don't. Secrets Manager is not limited to folders. Secrets Manager can be applied directly to individual records within your vault. It's just kind of a UI thing in terms of how you want to set it up. But the way that it works is that Secrets Manager shows up here on the left, and you've got these applications. I have a whole bunch of applications that I'm using. It tells you how many devices and how many records apply to them. So an application could be anything. It can be a software application that you developed. It could be a third-party tool like Ansible, like I have here, or it could be a specific machine like my computer or my desktop or some server. It can just represent, it typically represents some sort of a environment to target some sort of an application. So an example of this would be, I have a Java application here, which has some access to some secrets, or a Jenkins pipeline, and so on. So you can create these applications. Some of the language here is, I mean, some of the way I've named this is not so great, but here's a Puppet application and so on. So the applications relationship is that you have an application, and then you have one or more devices associated with that application. And you also have shared folders and individual records that can be associated with an application. So if you go over here to the devices tab of the Secrets Manager application, you can see the various devices. A device could be a particular machine. It can be an entire cluster. It can be my computer. It can be like a server that's running some script. So you can lock down devices. The whole point of devices is you can have multiple devices for a single application, and every device has its own identifier for tracking and auditing purposes. It has its own logs that you can retrieve, and it also has its own security settings. So a particular device can have specific access to certain secrets and also be IP locked. In addition to the encryption and the authentication that's taking place, it can also be IP locked for access to those specific secrets. So I'll just go through the process of kind of starting from scratch and creating a few different things. So I'll go over to, actually I'll go over back to Secrets Manager, and I'll click on Create Application. And so application, I'll call it, let's say Python script for August 4th. And then once you name the application, you assign the folders to it. So I'm going to assign the development secrets and DevOps secrets folders to this application. And then you can assign permissions. So the application itself could have certain permissions over those secrets that are stored in the vault. And I can have edit or read only. So I'll choose edit. Then I can also lock down access. So this is that first device that gets generated, the device profile, can be locked to the first request for access. So the first time that a target machine requests access to the secret, it's of course authenticating, it's decrypting the data, but it also is IP locked. So I generated a token. So this is what we call our one-time access token. And the one-time access token is essentially a transfer token. So this is generated here client side on the device. I click copy to retrieve it, and then from here, I can use it in my target application. So just for the purpose of demonstration, I'll initialize it with the Keeper Secrets Manager CLI, which is kind of representational of one of our endpoints. So KSM is the name of the utility, and it can be installed on any Linux machine, Windows, Mac, anywhere. And so I can just say KSM profile init with the token. And so now it has initialized that token. And it's, you can see here in the token configuration, it's got this US colon. So I'm using the US data center. If you're using the EU data center or a different location, that's going to be a different tag there just to help you out to understand where the endpoint is. So now when I type KSM secret list, I now am able to retrieve secrets directly from my vault. So it's generated some local encryption keys to be able to authenticate every single request. It uses a signing for every request to the server. It then retrieves the information, the ciphertext. It decrypts the ciphertext locally on my device and then presents it. So the KSM application, just for an example, if I wanted to say get this Oracle database credential, I could just say KSM secret get, and then the record identifier, and it retrieves that information. If I want to get the information in like a more machine readable format, I can say KSM secret get dash, actually let's say dash dash help to get the different options. So dash dash JSON gives me like a JSON structure, and then the record identifier, and then it retrieves the results in JSON format. So of course, you can think of a lot of different ways to use this. So if you're writing some command line scripts or some shell scripts or anything like that, you can use this to very quickly access any information from the vault that you've granted access to this application, and it can retrieve it in many different formats. So you could also query individual record fields. There's a lot of functionality built into the KSM utility. One of the things it also can do is wrap other programs. So it's got this KSM exec command, and the KSM exec command is able to wrap another application. And what it does is it will replace in that application any environmental variables matching a particular syntax, and it'll automatically retrieve secrets from the vault and replace it into those scripts. So that's really useful for things like shell scripting, or if you've got some legacy software or something that you don't want to mess with, and it's got hard-coded credentials, you can replace those with environmental variables that retrieve information directly from the vault by using the KSM exec, and then path to the software to the program. So that's one implementation of Secrets Manager and how that's used. So I've got this application, this Python script here, and we'll get into some of the different use cases. But I'll jump over to the admin console and just kind of show you how you can track and monitor some of the usage here. So if I go over to the Secrets Manager, this is a new tab here on the left, which appears, and it shows you the total number of API calls, the application owners and users, and the different devices that are communicating with the system. Every action that's taken is also logged within the Keeper event reporting system, the reporting alerts module. So if you go to a recent activity, you'll see here that under the events that just took place, here is me using some application just a little while ago for accessing a secret from a Python program. So the information here that's captured in the advanced reporting and alerts, for example, KSM device, certain device ID has accessed secrets from a certain application ID. So as always, the event logs do not show secrets. They don't decrypt data. So this can be safely exported into your SIM solution. So every single action across every device, every system is tracked with the advanced reporting and alerts module. Question. Okay, so GitHub. All right, so let's get into that. That's the next thing I was going to show. So I'll go over to the documentation for Secrets Manager. This really has everything you need. We'll kind of review some of this stuff. So we just went over the Secrets Manager CLI, which has, again, a ton of functionality for accessing secrets from the vault. But the next thing is the developer SDKs. So we've developed SDKs in every language, in every the most common languages. So Java, JavaScript, Python, .NET, Golang, and also PowerShell. And so the whole purpose here, this is really the use case of being able to remove hard-coded credentials from software. Very clean, super clean, really easy to use SDKs that have very, very common interfaces. So getting secrets, updating secrets, retrieving files, anything like that directly from the vault. So the question that was asked about integration. So integrations is the third major component. So you have common integrations that we've built that utilize our SDK. So each of these integrations, like Ansible, or in the question that was just asked around, we have a GitLab plugin, and we also have a GitHub Action plugin. So these plugins were built using our SDKs, and it allows you to execute and retrieve secrets directly from the GitHub Actions runner, like you just asked. And then it also allows you to modify information and do that sort of thing. So I'll kind of show how this works. So the GitHub action you can install, and it's also a part of our video. But a really simple example of this is you can see in this GitHub action script that within the GitHub action script you can do things like you can it'll retrieve the configuration, and then it will retrieve secrets from the vault. So where you had normally hard-coded credentials or secrets into the GitHub action scripts, you can now replace them with direct references into the secrets manager vault. And to show actually a real example of that, I'm going to show, because we like to eat our own dog food, we use secrets manager for deploying secrets manager. So this is our public secrets manager repo on GitHub. And by the way, you can all see this. It's a public repository. So all of the secrets manager source code for all the client apps, the SDKs, it's all public. So if you go over to the secrets manager repo, there is a GitHub folder, and this is where our GitHub action lives. So one of the GitHub actions we have is for publishing to Maven. And if you look at that file, I'll zoom in here. You look at that file, you can see that we retrieve secrets from KSM, and these are the secrets we need in order to publish to the Maven repository. So the keeper secret config, this is the configuration, which I can show a little bit more about that if there are questions. But basically, you saw that in the vault, I created a one-time access token. That one-time access token is used to initialize what we call a configuration, and that configuration is basically a base 64 value that's just plugged in here. The secrets that are retrieved from the vault, this is the record ID, so it's just one record, and there's a file attachment, and this is the name of the file attachment. So it's retrieved directly from the vault, and then it's put into a particular location here for usage. And then also we have some custom fields like a key ID, there's a password, and some other passwords. And so these are set as environmental variables in this case. And so this kind of gives a really simple explanation of how we use Secrets Manager in a GitHub action, and it's really simple. We have a lot of customers using this. This is a really, really, really common use case and highly used. So there's also a lot of functionality that's available in the GitHub action script. So you can retrieve secrets, you can retrieve custom fields, you can get files, and masking is enabled automatically for anything that comes from the vault. Is there another question?
Nope, not yet.
Okay. So the next thing I'll show is an example of source code example. So this is an example in the developer use case of hard-coded passwords in code, especially hard-coded passwords that are checked into source code repositories. So here's kind of like how things used to be before Secrets Manager. So this is some Python code, and you can see that it's making a connection to a database, and it's got some user and some hard-coded password, and the host name is also hard-coded in the code, and it runs some query against the database and then just prints out the result. So of course, this is bad practice by hard coding the passwords. And so with Secrets Manager, now I can just kind of show an example of what this looks like with Secrets Manager activated. So using our Python SDK, in this case, you're here, it's importing our Secrets Manager SDK, and it initializes. So the first thing it always does is it just initializes the SDK, again, with that configuration. That configuration is locked to this device. It can be IP locked. It uses a key to sign every request with the system. So this is how this is protected. And then you can see here that instead of hard coding the password, we're getting the secret directly from Secrets Manager. So Secrets Manager.getSecrets, and this is that record identifier. So this is actually just a public a public auto-generated ID. So this can be safely checked into your source code repository. So it retrieves the secret, the host name, the username, the password. So the password is just parsing that secret that comes back from the vault, and it grabs the password field. And then when it uses that to connect to the database, it's just connecting using variables that are safe to check in to the source code repository. So just to demonstrate it, of course it works. So I can just click play, and I have it where it actually works, and it retrieves information from the database. So this is that third use case of being able to integrate into source code.
Awesome. We did get a couple more questions.
All right, cool.
First one is, with the current SDKs, we need to touch all of our services. Are there any plans to provide Kubernetes operator or add a key provider to the external secrets project?
Yeah, so we do have external data providers. So I believe that's the question. So we've added a few different ones, and so let's just talk about one of them. So we recently added, as a data provider, we recently added the Azure Key Vault. So this allows you to use Keeper as the single source of truth, and then it will push information directly to the Azure Key Vault. So it'll basically use that to back storage. If there is something specific, and I do, now that you asked that question, I do think we had a request for that specific store. If you do have that need, actually send that over to us. You can contact Max, or there's an email that we'll distribute. But go ahead and send that over to us, and we can let you know if that's in the pipeline to be added. But yeah, so we are adding data sources. Like you can also use, in this case, actually for this HashiCorp plugin, this is for using Keeper as the data store for HashiCorp. But we also have built data storage facilities into it. So yes. What was the other question? So we do have a Kubernetes. We do have a Kubernetes integration, and so the Kubernetes integration provides a lot of capabilities around, of course, retrieving information from the vault. So there's different ways that you can use the integration. We also have integration into Docker containers. So if you're going to build a Docker image, you can build it using Secrets Manager. You can also, there's a runtime where when either the Kubernetes cluster, or if the Docker container starts up and runs, it can retrieve information from the vault then. So there's like a building phase that we integrate with, and then there's also the runtime, which we integrate with. And to your question, we can talk about the data storage for the Kubernetes. What was the question?
Yep. Next one is, are we planning to make an SDK for PHP?
I guess if we get enough requests, yeah, we can do that. You can probably, from the PHP, you can probably just utilize our KSM utility for now, and maybe wrap it that way. But it's a good question. We could probably do that, yeah. I don't know if Max is on, if we've had several requests for that, but I wanted to write one for Perl, but I think I would have gotten yelled at. So yeah, so we can consider doing one for PHP. Is there another question?
Someone just commented they've been calling KSM CLI from their PHP code.
Yeah. Well, it sounds like people are using it, so we could add one for PHP. I mean, that'd be fine. The CLI is actually really easy to wrap. It has it's really friendly to work with, but so that works.
But no other questions right now.
Okay, cool. So one thing I guess I didn't really show here is also custom record types. So we didn't really show any of the information. So if we go over to this example, so connection manager secrets, you can see that I've got different types of content stored. So I've got like a MySQL password. I've got a Linux SSH key, and an SSH key can be stored with kind of dumping the contents directly into a custom field. So we have a private key field. You can also attach the file for the SSH key. Here's another example of a MySQL database. And of course, something like a Windows server. So this is an example of a Windows administrative login. Now, the reason for this, and this is kind of leading into our, another use case for the secrets manager, is for establishing connections. Some questions were asked around SSHing and things like that. So here in Connection Manager, secrets folder, you can see I've got the users. These are the users who have access to manage the actual records here in the vault. And then I've got applications. So in the applications, one of them is here, connection demo environment. So our Keeper Connection Manager is one of the endpoints that integrates with Secrets Manager. It's one of our plugins. So if I go, for example, over to my demo environment for that, this is the Keeper Connection Manager, and Connection Manager is built using Secrets Manager integration. And so if I go over, for example, to settings, and I see my my different connections that I've got going on, I can look at, let's say, this Windows server. And this Windows server, it's a connection that I'm going to make to an internal network, an internal Windows 2022 server. And it's got a host name. This host name is the lookup parameter that it looks up into the Secrets Manager. And you can see for the authentication, we're using some tags. Keeper server user and keeper server password. This is just a tag. It's like a reference from Connection Manager over to Secrets Manager. So this is how the association in this case is made between the connection and between the record in the Keeper vault. And so the end result is that if I want to connect to this target with Connection Manager, it retrieves the secret directly from the vault. And now I'm able to establish a privileged session over to that target instance all through my web browser. So this is the Keeper Connection Manager product. And then it kind of shows you also, the ability to also access things like SSH targets and utilizing information from the vault and utilizing information from the Secrets Manager. So this tight integration allows you to do not just CI/CD and direct integration into the vault, but also allows you to establish connections with Keeper Connection Manager, utilizing those secrets, and it never exposes those secrets to the end user. So I can assign permissions to be able to access, for example, this Windows server or this Linux server. I can assign permissions. I can assign connections to different people, and it preserves zero knowledge. Also, of course, these are recorded. So if any of the sessions that take place, if you decide to turn on recordings, you have the ability to pull up logs and see all of the activity that's taking place with these connections into these targets. So the benefit of this is that you have, of course, the secrets stored in the vault. You've got the humans that can interact and work with all the data that's stored inside of the Keeper vault. From all my different applications, whether it's the desktop app, web app, mobile devices. And then you have these applications that can pull specific secrets and use them for things like replacing hard-coded credentials, publishing software, establishing connections to remote systems like this with Secrets Manager or with Connection Manager. Is there another question?
Nope, they're just admiring the Yoda on your desk.
Oh, he helps me out. So one thing I'll also show is, I guess I didn't get into it here, is the Keeper Commander interface. So everything I've showed you so far is using the Keeper Secrets Manager CLI. and using the Vault interface, but a lot of this can also be done with Commander. So Commander is our CLI. If you haven't checked it out, please do check it out. It has a ton of capabilities. So I can sign into the Keeper Commander CLI, and from here I can also manage all of my applications and my secrets. So there's some specific commands that are built just for Secrets Manager. So if you do question mark, you can see all the different commands that are available. So Commander has a ton of capabilities. It can do reporting, it can create content, it can do administrative things, it can create shares, it can do everything that the Vault and the admin console can do. But it also has some special capabilities. So it has the Secrets Manager command, and the Secrets Manager command has the ability to do everything all from Commander. So you don't have to use the Vault for managing secrets. So for example, Secrets Manager app list will give me a list of all my applications. Secrets Manager app get will give me the information. So here's that Python script, August 4th, the one we just created. Is it app get? Yeah. So I did a Secrets Manager app get, and it tells me the app name is the Python script, app UID, and then it tells me all the client devices that are connected to it. So in this case, I've got this one device here that was accessed, last access time, IP lock enabled, and the IP address, and also which folders it has access to. So I can do all the management of secrets, assign secrets to applications, assign applications to folders, assign applications to individual records. I can do all of that through the command line tool. I can also generate configurations. So one of the things here is that we have the ability to generate a config, we call it. So it's a Secrets Manager client app command. So as you can see here, you say Secrets Manager client add, and then you specify the app name, and then you can specify some parameters. So you can unlock the IP, which means that it will be available to any address that accesses it, or you can allow it, which is by default, it'll lock down that IP. You can assign it a friendly name. You can say when it expires, when that one-time access token expires, how quickly can it be used? When does it expire access completely? So you can set an expiration date on the device itself. So if you want to provide only short-term access to that device, you can specify this. And by the way, this is you don't see this in the user interface. So there's some advanced functions that are built into the command line tool. Again, the IP lock you can assign there. You can auto-generate a bunch of different tokens all at once. So if you have, you want to distribute this to a cluster, or you want to generate 100 access tokens, you can do that all with one shot. And then you can specify, we call it config init. And so the configuration, the Keeper Secrets Manager configuration, can be generated in either JSON format, base64, or a special format for Kubernetes. And so when you're setting up your third-party applications, the whole reason for this is that in these integrations, let's say the Ansible integration, or let's say the Key Vault integration, different integrations utilize different configuration formats, and that's how those are used. Okay. Any questions? Any remaining questions?
Not that I can see right now, but
okay,
if everyone
great.
does. Yep.
Great. So let me I'll stop sharing. Let's get back to the presentation. Can you actually, do I click that? Or can you turn that back on?
Yeah, I got it.
Yep. All right. So just jumping over to pricing now. The pricing is actually changing. This is the new pricing structure. So this is, some of the people who have seen it, it is a little different. So the way that we've adjusted pricing here to make it really great for users is that we're now providing unlimited secrets, devices, integrations. And so there's a flat fee of $2,400 per year. And so that's unlimited users. So instead of, at first we were doing this based on the user license model, and it was confusing a lot of people. So instead of doing this based on users, because the number of users for Secrets Manager is obviously different than Vault users, and it was complicating things. So basically there's going to be a flat fee here for the $2,400 USD for unlimited users, and that includes 2,500 API calls per month. So outside of that number of API calls, we're charging blocks of 2,500 API calls for 20 USD per month. And again, that's just unlimited usage of the platform. And that also, as we discussed before, there's actually a cached version for the users. So all the SDKs and all of the integrations have the option to activate an offline mode. So in case the keeper's not available or your internet's got an issue, it will retrieve ciphertext from the local cache, so you won't be in any sort of an outage situation. All right. Well, thank you very much. And you can reach out to sales, but also we do have a public Slack channel. It's linked over on the Secrets Manager documentation, and you can join our Slack channel. It's called the Keeper Beta Slack channel, and so most of us on the Secrets Manager team are hanging out there. So if you have questions, feel free to shoot those over to us, and look forward to working with you. Thank you.
All right, thanks, Craig. And then I am putting one quick poll on the screen. I just sent it now. So if you would like a custom demo of Keeper Secrets Manager to go over your specific use cases, feel free to click yes there, and we'll have your system reach out. If not, go ahead and skip it, and we'll be providing the recording and the instructions to start a trial yourself in an email following up today. So thank you, Craig. Thank you for everyone for joining, and enjoy the rest of your week.